In this video, we'll consider a constant angular acceleration problem. Constant angular acceleration implies that one can use the rotational kinematic equations. So we have three equations that we can use. Theta is theta naught plus omega naught t plus 1/2 alpha t squared. Omega is omega naught plus alpha t, and omega squared is omega naught squared plus 2 alpha delta theta. I often go through and actually fill out a table just as I do in linear land. I have theta naught, I have theta, I have omega naught, I have omega, I have alpha, and I have time. Just the way I did back in chapter 2. In this problem, it says that t equals 0. It has an angular velocity of 2 rads per second. 2 seconds later, it is turned through 5 complete revolutions. That would be 10 pi radians. And initially, we'll say that it was at 0 rads because we can start our axis anywhere we want. It says, what else? 2 seconds, that's t. We have 2 unknowns and 3 equations. So there's 2 things that they will ask you. They could ask you the final speed, and they could ask you alpha. All right, let's see what they want to know. They want to know the angular acceleration of the wheel. They want to know alpha. So any equation that has alpha will work. This equation, and that equation. If I look at this one, this has the final angular speed and I don't know it. This one has the final angular speed and I don't know it. So while you could use this equation and this equation up here and solve it, that wouldn't make sense because both of them have 2 unknowns. Quicker would be to use the top equation. I don't know alpha, but I know t. I know omega naught, theta naught, and I know theta. So only one unknown. Let's do that. I have theta minus theta naught minus omega naught t is 1/2 alpha t squared. That's 0. Therefore I have alpha t squared is 2 times theta minus omega naught t. So alpha is 2 times theta minus omega naught t divided by t squared. Have everything I need to plug and chug into this problem. Alpha is 2. I have for theta 10 pi rad. And then minus, I have omega naught 2.0 rad per second times the time. The time is 2 seconds. Seconds cancel and I'm in radians. And on the bottom I have 2 squared. Grab my calculator and simply punch it. Ten times pi minus 4 divided by 2, 13.7 rad per second squared. So that's if you only keep 2 sig figs, 14 rad per second squared. And that would be the answer right here. And that's how you solve a problem using the rotational kinematic equations. It's just like using the ones for translation. Fill out your table. Make a good drawing if necessary so that you can find these values. Write your equations that you have using the big board to translate the equations over into rotational land, and then see what you know, and start simplifying the equations. Straightforward. Shouldn't be hard. It's exactly like they were in Chapter 2.